just so that you know what to do with your cheat sheet and all of that stuff. So the only reason we're doing it over 2 days is because some of the problems just take a lot of time. Like for example, the verifying identities problems. It's hard to see what to do right away on those. Sometimes it takes a few minutes. So again, that's the only reason we're breaking it up, just because some of the problems take a lot of time and I don't want you to be rushed. So you can write down whatever you want of this, but this is just kind of explaining how it's going to work. It says the Chapter 5 test will be taken over the course of 2 days, Thursday and Friday. I had my days mixed up yesterday, so make sure you have that, Thursday and Friday. And I put up here also that it's not going to necessarily be broken up by section. Like it's not, 5-1 and 5-2 tomorrow and then 5-3 and 5-5 for Friday. I couldn't do that because some of what we learned at the beginning of the chapter, like solving equations and stuff, we ended up doing that again later in the chapter. So it's hard to break it up in that way. So that means you'll get to use the same one-sided full cheat sheet for both days. When you finish your test tomorrow, instead of stapling your cheat sheet to the back, I'll probably just have you make a pile of cheat sheets, and then I'll pass your cheat sheet back to you on Friday when you get in here, and then you'll use the very same cheat sheet then. Again, I don't think you need more than one cheat sheet, just because, again, it's not that there's a lot of material, it's just that some of the problems take a lot of time. So again, one full one-sided cheat sheet for both days. You'll turn it in tomorrow and get it back on Friday. So don't make 2 cheat sheets. You only get to use 1. Any questions about how that will work? Handy dandies you get on both days too, of course. So I'll go ahead and just start section by section like I usually do, reviewing a few things. I won't be able to go through everything in one class period, so it's still up to you to look back through your notes and your homework and all that to add more to your cheat sheet later on. Okay, and this is our first set of directions. I think I'm actually only doing one example from 5-1. Hello there. All right, we're reviewing here. So we just got started. This is section 5-1. And it says, use the given values to evaluate the remaining trig functions. And I know for sure there is one on the test very similar to this. Use the given values to evaluate the remaining trig functions. Nolan and Michaela, I just explained it in the test Thursday and Friday over 2 days. You'll get to use the same full one-sided cheat sheet both days. So it's not really broken up by certain sections on each day. It's just kind of over the course of 2 days. So if you want to start your cheat sheet now, you can. And this is the first one. Only one of these that will do. Example 1, tangent of theta equals 2/3, and secant of theta equals radical 13 over 3. Radical 13 over 3. We know what tangent is. We know what secant is. It's our job to find all of the other trig functions. Sine, cosine, cosecant, and cotangent. So there's 4 more to find. Now, in order to start the problem, I kind of like to make a right triangle so that I can use all of that information to label it. But we probably should check and see what quadrant we're in. That way we make the correct right triangle. We want to draw it the right way. So I'm looking for the quadrant where tangent is positive and secant is positive. Which quadrant has both of those being positive? Yeah, quadrant 1. And so then I can look at the top of handy dandy, and that is how I should make my right triangle. Got theta in the bottom left and then the right angle down here. Okay, so labeling this, I know tangent is opposite over adjacent, so that would be 2 over 3. I've got opposite of 2, adjacent of 3. And secant is hypotenuse over adjacent. We already know the adjacent side is 3, so that's pretty much just telling me what the hypotenuse is. You could have even done the Pythagorean theorem to get the hypotenuse, but that's just going to be radical 13. So now I'm just going to make a list in no particular order of the 4 trig functions that I still need to find. Okie doke. I got sine, cosine, cosecant, and cotangent. Here we go. Sine is opposite over hypotenuse. That would be 2 over square root of 13. Now I don't want to leave it like that. Let's rationalize that. Multiply by square root of 13 on top and bottom. So you get 2 square root of 13 over 13. Okay. For cosine, you can look at the triangle and do adjacent over hypotenuse, or you can flip over secant that they gave you at the beginning. But either way, it still needs to be rationalized. So multiply by square root of 13 on top and bottom, and you get 3 square root of 13 over 13. Now cosecant, do the easiest way possible. For cosecant, I want to flip over sine, but not that one. I'm going to go back to what sine started out as. Flip that over and you won't have to rationalize. It's just square root of 13 over 2. And cotangent, you can just flip that over. Whoa, 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 too far. There we go. And that should be just 3 halves. So only had to rationalize a couple of them. Now I'm thinking of other things that happen. Go ahead.
You're okay if you rewrite tangent and secant, right? I have like a little...
Oh yes, sure, that is fine. I'm kind of that way too. I like everything to be lined up. So yes, that's okay if you redo those. A couple other things that I remember happened in our notes. First of all, you may not always be in quadrant 1. If you're in a different quadrant, your triangle will be different, of course, but then some of your sides could be negative. So negatives are something to look out for. We didn't have any here because we were in quadrant 1, but just telling you that could happen. And also, we had to look out for suspicious fractions. If you remember that, it would be like if this one had square root of 13 over 13. That would be suspicious. And I know it's suspicious when it's not matching up to what I had on the other side. If you're not getting things to match up, be on the lookout for suspicious fractions. You may have to rewrite them the way that they were before they were rationalized. Okay, so again, review days, I try to go over a lot, but make sure you look back at other types of problems in your notes. Any questions on example 1? We're moving here on to section 5.2. This is a good one. In section 5.2, the main thing that you need to know how to do is verifying identities. Verifying identities. I'm going to put a big star next to this. We're only doing, I think, one example in the notes today just to save time, but there's definitely going to be more than one on the test. So if I have extra my cheat sheet, I probably want to put more examples of identities because these are kind of tough. And you know, some of the problems that I put on the test could be very similar to ones that we've already done. So again, I would strongly suggest that you add to this on your cheat sheet. Okay, here's the one that we'll do. Example 2, tangent of x divided by 1 minus cosine squared of x, and it equals secant of x cosecant of x. Now remember what we did here. We always kept the right side worked on the left. It is slightly annoying, but you need to carry both sides down in each step. So keep the right, work on the left. Now, is there anything on the left side that sticks out to you? Anything over here? Yeah, that's kind of where my eyes are drawn as well. 1 minus cosine squared of x, surely that's a Pythagorean identity, and it is. 1 minus cosine squared is the same as sine squared. So for the time being, I just left tangent on top because I don't really know what I need to do with that part yet. And then I took the Pythagorean identity and used it for sine squared on bottom. Now, keep the right, work on the left. I'm thinking of tangent and sine. Is there any way we could rewrite tangent to have a sine, or any way to rewrite sine to have a tangent? Any ideas? Quotient identity. If you look at those, tangent is the same as sine of x over cosine of x. That's what I'm going to put right up here on top. Now, you're still dividing that by sine squared, and you still have the right-hand side, even though it is slightly annoying. Okay, and then my next step would probably be to just keep, change, flip. I want to do that, and then hopefully something nice happens. Keep, change, flip. I'm going to keep sine of x over cosine of x, change it to multiply, flip sine squared. If you flip that over, it'll be like a 1 over sine squared of x. Keep the right side, bless you. Now, I do see something nice that happens. You can divide this diagonal by sine of x. Sine of x divided by sine of x is just 1. Sine squared of x divided by sine of x is still sine of x. Now, if you show what I have up here, where you've got the 1 here and the sine of x down there, I can probably tell from this step what's going to happen. For the PowerPoint, I tried to make it look nicer. This can be just 1 over cosine of x. That can be 1 over sine of x. And now maybe you can see a little bit better that these are just reciprocal identities. 1 over cosine is secant, and 1 over sine is cosecant. But again, if you show this work right here, where you cross these out, put a 1 there, put a sine of x right there, you probably can leave that step off. I can see from here that it's going to be a reciprocal identity. All right, but I'd say every other step up there is important. Make sure you show all those others so I know which identities you used. Any questions on that? Again, we're only doing one of those, but there's definitely going to be more on the test. So add to that on your cheat sheet. Put more examples. That way you are prepared. There will be more than one for sure. Now, we'll try a couple examples from 5.3 next. And the main thing that we were doing was we were solving equations. It says find all solutions to each equation. Find all solutions to each equation. Anytime you solve an equation, you're trying to find what x is. So that's the main goal. Now, this is example 3, and it says 2 sine squared of x minus 3 sine of x equals -1. Anybody know what we should probably do first? Yeah, we want to get everything to the same side, so that's a good idea. Add 1 to both sides. Now, we actually had something similar to this on the worksheet yesterday, if I remember correctly. Think about this as a normal trinomial. 2x squared minus 3x plus 1. If that's what I had and I was going to factor it, 2x times x is how I get 2x squared. Both signs are minus, and it's yucky factoring, so I'm only picking numbers that multiply to 1. You can FOIL that out to check if you like, but I think that's the way it has to be. That would make your -3x in the middle. So that's good, but in our problem, we want to change the x's back to sine of x's. So it says 2 sine of x minus 1 times another sine of x minus 1 equals 0. And now that you have a product equaling 0, we should be able to break those apart and then figure out what x is. Okay, so on that left-hand side, we're going to have to add 1 and divide by 2. So that now says sine of x equals 1/2. And I can look at handy dandy to figure out the rest of that. Under the sine row, you're looking for where sine is 1/2. And that would be at pi over 6 and 5 pi over 6. On the other side, you're looking for where sine is 1, and that is just pi over 2. Okie doke. Find all the solutions. You got to go all the way to where you figure out what x is. Okay, now I'm going to do another equation here with number 4. And this is a very good review problem. There's a lot in this that we need to remember. It says radical 3 tangent of 3x equals 1. Radical 3 tangent of 3x equals 1. I don't like the radical 3 out front. There are a couple ways you could get rid of it. You could square both sides to get rid of the square root, but then you'll have a tangent squared of 3x, and you'll probably have to square root later, and that's a little bit more work than we have to do. So I'm just going to treat it like a normal number. If a number is multiplied by our trig function, we can just divide to get rid of it. Now it says tangent of 3x equals 1 over square root of 3. Now we probably don't want to leave it like that. You're not going to find that anywhere on handy dandy. So rationalize, multiply by radical 3 on top and bottom. Now it says tangent of 3x equals radical 3 over 3. Now, pay close attention to this part. Because of the 3x, this is what we called a multiple angle equation. We spent an entire day, one whole lesson, on multiple angle equations. You have to do them a little bit differently because it's not just tangent of x. In this case, it's tangent of 3x. That's what makes it a multiple angle equation. So for just a second, let's pretend. I'm going to actually write the word pretend because this is not saying that this is what I have in this problem. I'm just pretending for a second that it was just tangent of x equaling radical 3 over 3. If that's what it said, then I would look at my table for all of the places where tangent is radical 3 over 3. And that is pi over 6 and 7 pi over 6. Those are not our answers, but they're going to help us get our answers. We don't want x to equal those numbers. We want 3x to equal those numbers. So we need to set 3x equal to pi over 6 and 7 pi over 6, and then we can get x by itself. So dividing by 3 is like multiplying by 1/3. That's going to be a pi over 18. And same over here, dividing by 3, think of it as multiplying by 1/3, so we get 7 pi over 18. There is a very good chance that you'll run into a multiple angle equation on the test. So look out for it. And again, it's when it's not just x. In this case, it was tangent of 3x. Any questions on that? All right, that's good from 5.3, I think. Moving on to section 5.4. We are only doing one example from this section, but it's in a few parts, which is why we're probably only going to do one. It says find the exact values of sine, cosine, and tangent. We're in 5.4. Find exact values of sine, cosine, and tangent. By the way, there's a bunch of formulas in section 5.4. It was all of our sum and difference formulas. I'm not putting them all back up here right now, but they're in your notes somewhere, so make sure at some point before tomorrow on your cheat sheet that you get all of those formulas on there. Okay, example 5 says 345 degrees equals 300 degrees plus 45 degrees. If you look at the table on Handy Dandy, 345 is not on there. It's not one of our hot spots on the unit circle. It's not an angle that's used very often. However, 30 and 45 are. They're both on the table, and those are both considered hot spots. So we've basically found two angles that add up to 345. The sum has already been found for you, and I'll go ahead and tell you on the test. I can't remember if these problems are on tomorrow's part or Friday's part, but wherever it is, this will be given to you. You won't have to find your own pair of angles that add up to whatever that part will be there, so that is hopefully going to save you a little bit of time as well. It might be in degrees or it might be in radians, but either way, the sum or the difference, whatever it is, will be given to you. So I'm going to start by finding sine of this sum. Now on the PowerPoint, I actually put sine on both sides, but I mean really for the rest of this problem, I'm not really looking at the front part anymore because again, 345 is not on handy dandy, but those angles are. Now you may or may not have your formulas in front of you. If not, let me at least give you what this formula is. This is going to match up to the sine of u plus v formula. U is 300, v is 45, and here's what it said. Sine of u cosine of v plus cosine of u sine of v. It's in your notes. I think I even printed out that slide for you at some point, but they're in there somewhere. Sine of u plus v. So when we spread this out, we need sine of u first. So that is sine of 300. Then we need cosine of v, which is cosine of 45, plus cosine of 300 times sine of 45. You've got 4 different things that you have to look up on handy dandy, and then we can multiply everything together and simplify. Okie doke. So I'll start at the beginning. Sine of 300, that is negative radical 3 over 2. Cosine of 45 is radical 2 over 2, plus cosine of 300, which is 1/2, times sine of 45, which is radical 2 over 2. Multiplying fractions, you don't have to have common denominators. It's just a coincidence that they are the same, but you still have to multiply them. So 2 times 2 on bottom is 4. The negative square root of 3 times square root of 2, that's negative square root of 6. Plus, on this side, it multiplies up to be square root of 2 over 4. And anytime your denominator is already the same, go ahead and just make it one single fraction. Okie doke. So negative square root of 6 plus square root of 2 all over 4. Now, we still have a couple more parts. That was just sine. So now I'm going to find cosine of u plus v. That's on my next slide here. Cosine of u plus v. Here we go. Cosine of u, cosine of v, minus sine of u, sine of v. That is that. So again, u is 300, v is 45. I want to take cosine of 300 times cosine of 45 minus sine of 300 times sine of 45. Now you found all these numbers earlier. They're just in a different order. Okie doke. Here we go again. Cosine of 300 is 1/2. Cosine of 45 is radical 2 over 2 minus sine of 300. That was negative radical 3 over 2 times sine of 45, which is just radical 2 over 2. And a lot of it's the same, as far as how to simplify, make sure that you made it a plus sign. Radical 2 plus radical 6 all over 4. That would be it for cosine of 300 plus 45. Okay, any questions about that? Now, last part to the problem is tangent. So here we go. I'll try to put this formula back up here. Tangent of u plus v equals tangent of u plus tangent of v all over 1 minus tangent of u times tangent of v. Okay, adding on top, subtracting on bottom, you'll have tangent of 300 plus tangent of 45 all over 1 minus tangent of 300 times tangent of 45. Now, on bottom, you're going to have a little bit more simplifying to do. The top, we don't have a whole lot to do. Tangent of 300 is negative radical 3 plus tangent of 45, which is just 1, all over 1. I'm going to change it to a plus. It was 1 minus negative radical 3 times 1. But again, those two minus signs there should just turn it into a plus. So 1 plus radical 3 on bottom. The answers for tangent always look a little weird. Now, I will say on this problem, the only formulas that we used were sum formulas. Sine of u plus v, cosine of u plus v, tangent of u plus v. You never know, you might need a difference formula on the test. So add those to your cheat sheet as well. It would say sine of u minus v, cosine of u minus v, tangent of u minus v. Just make sure that you've got them all on there. Any questions about those? Okay, last section here is 5-5, and again there's a lot of formulas that you'll probably want on your cheat sheet. We had double angles and half angle formulas. They're not on handy dandy, they're not given to you. We should have some extra time at the end of class today for you to get all those formulas on your cheat sheet. But I'm just going to do one example from 5-5, and it looks like it involves a double angle. It says find the exact value of sine of 2u using the given information. Exact value of sine of 2u using the given information. I'll go ahead and give you that information right now. This will be number 6. Cosine of u equals negative 2 over square root of 5. So that's kind of different. It's not been rationalized, but that's all right. And it also says, in a fancy way, that u is between pi over 2 and pi. Now, if u is between pi over 2 and pi, what quadrant is that? Quadrant 2. So that's how I need to draw my right triangle. Now, I can't guarantee on the test that you'll be in the same quadrant, so make sure you know how to find that. It's like the axes of the unit circle. Pi over 2 was at the top, pi was down here. At the bottom, it was 3 pi over 2, and then at the right, it would be 2 pi, or 0. Okay, now I can use this to help me label my triangle. Cosine is adjacent over hypotenuse, so -2 on bottom, radical 5 for the hypotenuse. And I'll probably go ahead and do the Pythagorean theorem real quick to figure out what that missing side is. Okie doke. It's got -2 squared plus b squared equals square root of 5 squared. Now what happens when you square a negative? Turns positive. So make sure you do that. But then you do have to subtract the 4 and square root both sides. If we're in quadrant 2, should this side be positive or negative? Positive. So look out for that. Again, it depends on the quadrant that you're in, but for this problem we needed it in quadrant 2, so that side should be positive. Now, what am I even doing here? I'm supposed to find sine of 2u. Again, this is another formula that you'll want on your cheat sheet. You might be asked for cosine of 2u or tangent of 2u. I don't have any examples with those today, but it's just more formulas that you'll want to add. Okay, here we go. I got to take 2 times sine of u. Sine is opposite over hypotenuse, and I don't want to rationalize that yet because I think they will rationalize themselves. Cosine of u, you can get it from the triangle, or that was something that they gave you at the beginning. Now, this would turn into -4 over 5. Square root of something times the square root of the same something is just the something. Okie doke. Again, you might be asked to find the double angle of cosine or tangent or even a half angle. So I'm going to go ahead and just kind of list all those formulas that you need to make sure and put on your cheat sheet. This is kind of like your assignment, I guess, for tomorrow and to study for the test. But sum and difference, double angle, half angles, you'll want all of those to be on there.